Great. Okay. So let's make sure everybody's here with us. If you are here with us, please either say something or wave your hand so we can get started. If you can hear me.
Yeah, I can hear you.
Yes, I can hear you.
Okay, so I would assume that everyone can hear me. Somebody disappeared. Who was that? Okay, so yeah. First of all, thank you for being here. We had an amazing week. This last week, rather, we talked extensively. Well, not talked. I sent you materials about introduction to programming. I also I made a recording of a video to explain how you need to set up Python on your computer, how you need to set up Python on your computer, how you need to, open a new script, run a script. Over the course of the week, over the course of the topics, rather, it will make more sense. All right. During the course of the week, we had a Q&A session, the question and answer session on Wednesday, where I tried to clarify again what the objective of the week was. I also, answered some questions that others had. And so ideally, what we do today on Sunday is that I would have like a review of the topics. So usually, I'm sure most of you have seen this in the orientation video already. Usually there are lists of tasks that are published on a Sunday on the Google Classroom that you're supposed to finish by the end of the week. So the Sunday that follows is usually when I would organize the code review session. And what code review session really means is just I'll take a look at everybody's code. We'll have a kind of live call where I try to just give my 2 cents or my inputs about people's code. Because as we start to go deeper into this, one of the things you realize is that 2 people's code will be very different. I think you shouldn't realize that this week. So because this week does not have a lot of coding, but just mostly a quiz that I think everybody except 2 people didn't do. It was really a quiz that everybody except 2 people didn't do. We'll probably just review the quiz. There were a number of materials that I posted on the Google Classroom. I mentioned where I got them from, this first 4. So I'll kind of give you a kind of brief, a summary of what those videos are for some people that didn't get it. Okay. A number of the things that the guys said, they were quite useful. Yeah, as a developer, you're generally a curious person. So a number of the things that it would teach you, or it would say rather, should generally just feed to your curiosity. Okay, so before I start, before I go deeper into the explanation, I want to make sure everybody's with me. Can you all hear me? I think Blessing joined in. Blessing and okay, just Blessing. Okay, so everybody's with me. Blessing, can you hear me? Yes, okay.
I can hear you.
Awesome. I realized that I took away from your show. Are they done with the Big Brother eviction show?
Yes, yeah, done.
So how many people were evicted today? The 7.
4.
Just 4. Okay.
Yes.
Oh, yeah. No problem. I hope you had fun. Anyhow, moving on. So in all of these 4 videos that I posted, one of the most important, and I say important, like it's the most important thing that this guy kept trying to reiterate or repeat was the need to be able to think, and I'm going to say a big word here, but bear with me, algorithmically. Yeah, like to be able to think using algorithms. That's the best way I can explain this. So what that really means is that the guy really looks at programming from a computational perspective. And when I mean computation, I basically just mean how you can get the computer to solve a problem for you. All right. We all know that we're in the technical age or in the computer age where everything is basically digital, right? So that means that many of the problems that we face in the current generation that we are would be digital in nature, as it were, or would at least the solutions would be digital. The solutions would be on a computer of some sort. So thinking about things computationally means that you're thinking about problems, you're thinking about how you can solve a problem using a computer. That's just what it means. And one of the major things that you should be able to know how to do is, where you're doing that, is use algorithms. Algorithms are basically just a set by set instruction of how you would and how you solve a problem. It's straightforward. An example would be, let's say, for some of us that work in the fitness industry, if you have a client come to you for the first time and says that she currently weighs 100, or he currently weighs, I'm not trying to be gender biased there, but he or she currently weighs 130 kg, and they want to get to, say, 80 kg after 7 months. I don't know if that's possible, but I guess it is. Now, as a client, as a fitness trainer, you would have a set-by-set procedure of how you go about it. You first of all collect some information like their BMI, their weight, their height, all those information that you collect. So first, determine what their body mass index is, what their fat percentage is, and all of that. But the next thing you want to do is, you're not going to start thinking about processes. What kind of workouts can they do? The next step, you think about workouts. You start to have a plan, create a plan for the workouts to do. The next step you want to do is you want to create a diet that they'll be following. And then like that, you're coming up with a kind of recipe. Now, that's a very broad example. A more specific example, for instance, would be finding the square root of a number. Oh my God, I wish I had my plan. Finding the square root of a number. I think the guy referenced that in knowledge. I would go into it right now, but it can be a bit complicated, especially since I don't have a whiteboard there. So if you want to understand how to find the square root of a number, I recommend you watch this one again. The guy really explains it, and if you want me to explain some part that I didn't get to, let me know privately. But I'm not going to get into it because it can be a bit long-winded. Is everybody following me?
Yes.
Awesome. Any questions so far?
No question.
Okay.
I'm not really good with those videos. That's the issue.
Okay. Godwin, how about you?
Sorry, the BMI, the body mass index part that you said.
Yeah.
So you haven't finished that topic. Are you still going back to that topic, or you're just?
It's not a topic. I'll just give you an example.
That's an example.
Yeah, it's not something big. I'm just saying that BMI, it's one of the things you would do to try to determine how to get your client to lose weight over a period of time. So in the process of creating a plan, that will be one of those things. I'm just trying to use that to explain what an algorithm means. Do you understand?
Okay.
Oh, I know that you're a fitness guy. Oh, by the way, that's Godwin. He's a fitness guy. I know that kind of stuff appeals to you. So I'll try once in a while to find examples along that line.
All right.
Any other person with questions? Sheun, Smith, Darako?
No.
Okay. All right. Good. So what I'll probably just go. What? Did somebody say something? Okay. All right. Let's just go straight into the questions. I'll try to answer one of them each other one after the other. So the first one says, what's the difference between an algorithm and a program? And like I said, this guy really explains it especially in the knowledge part. But to give you another example of what an algorithm and what a program is, think of, okay, you currently want to build a house, right? You want to build a house. I think have I given this example before? I feel like I have. But I'm going to say it again for the benefit of those that didn't hear me the first time. You want to build a house, right? So in your mind, you have this idea of what the house you want to build. You have this, okay, this is how it's going to look. These are the things that I need to do, blah, blah, blah. And first lay the foundation for a 3-bedroom flat, or for a 2-story building, or for whatever. I need to do this. Then I need to hire an architect. And I need to pay for this. Then I need to do the furniture. So you have like a step-by-step process of how you get that idea of the house in your mind. Now, the step-by-step process is what you will call an algorithm. Then the program is basically what that step-by-step process will result to. So when you have that step-by-step process of how you want to build your house, when they finish building the house, the program will now be the house itself. I don't know if that makes sense. So the perfect answer here for what's the difference between an algorithm and a program is the first one. An algorithm is an idea. You have the idea in your mind. You have a kind of structure, a process of how you want to solve the problem. Then the program is now when you've taken that problem and you've written out, like you've typed the code into Python or into C# or into whatever. This is something we're going to be doing repeatedly over the course of the next few weeks. We're going to see problems from an algorithm perspective and then try to solve it and then create a program for those problems. So here, an algorithm is a conceptual idea. Conceptual is just a big word. It just means the concept. And the program is an instantiation of that idea. It's basically what you get, basically the output of the idea. Now, I said something, I'm not sure if I've said this before, but this program is not going to teach you how to think. I'm not going to say, okay, I'm not going to give you a problem and then solve it for you. What I'm going to teach you is, what you're going to do rather is you're going to go and think of how you're going to solve a problem. You're going to think of the conceptual idea. What I will do is I'm going to tell you how to write those solutions into programming. Now, this was something I told Blessed at some point in time. It is very popular for programmers to be what we call problem solvers. Like they oftentimes get lost in their head, like they think and think and think so much that, I think sometimes it's even a fault. So you look at things around you. I want that to be like a second nature for you. If you're able to look at things, you don't have to solve it. Just think about the solution. An example would be, let's see. An example would be, I don't want to say Nigeria's problem because that one is bigger than anybody. But, wow, no idea is coming to my mind. Okay, currently, if you live in Lagos, you know that they're currently fixing a lot of roads, right? And that's a problem because it's causing serious traffic and movement has been terribly slow. So, I'm not saying that you should now write a proposal and then submit to the governor of Lagos State. No, I'm just saying that you see that kind of problem and then you just think, okay, how best can we solve or can we minimize the traffic in this situation? Currently, they are fixing Dia, they're fixing Bagada, they're fixing Akoka, and then there's just serious traffic. And then you just sit down, they're taking a walk one day and like, okay, what's the best way to solve this problem? That's just one out of many. There are many problems that we face every day. Many problems that we face every day. Some people have financial problems, people that don't know how to save. People that have terrible spending habits. How best can you solve their problem? People have weight issues. For the fitness guys here, how best can you solve their problem? You can think of simple problems. I'm just trying to expand your mind there, but there are no limits to any problems that are there. What I want you to do is that I want you to just have this nature where you're able to see problems and then just think of solutions. You don't have to implement your solution. I just need you to think of them, because what that does is that you're training your brain to be able to think out of the box. And that is a very important skill for programmers. All right? Does everybody get that? If you get that, please wave your hands.
Yes.
Great. Does everybody get that, or does anybody have any questions? Okay.
I get.
Okay. All right. So I would assume that everybody did. Now moving forward, the two things that every computer can do is perform calculations and remember results. And this is, it said in the video really, I'm just going to reiterate what it meant. And I'll try to give you as an example. I'll try to create the kind of narration here. One of the things that you would notice that man has been doing since the very beginning, from the Stone Age to the, what do you call that other age again? Is it the industrial age? I think there was an age between Stone Age. I can't remember. Let me quickly do a search. Stone Age, industrial age, information age. Yeah, there were a number of them. Yeah, the number of them. So like there were different phases in the period of man existence that man basically had all these technological innovations. Like man created all these crazy things. So in the Stone Age, you had stuff like, they'll be killing animals with stones. If you want to hunt an animal, you have to stone it or something. And then you fast forward to an industrial age where man found out about metal. And they started to develop guns, the atomic bomb that bombed Hiroshima and Nagasaki, right? And now we're currently in the information age that basically deal with computers. Now, one of the things, you can do your research later and just find out more about all these ages. One of the things you would notice about the progress is that we're constantly looking for how to make ourselves better. So let me rephrase that. We're constantly looking for how to make the things we do easier. Now, man itself, we are limited. And what I mean by that is, many of us today, if I ask you, what did you have on your 50th birthday, except you're kind of crazy ass genius, that's the ones they show inside movies, you would not remember. Or if I ask you to do 89 times 89 divided by 26, all raised to the power 3, I'm pretty sure nobody will figure that out here, except, of course, again, you're a genius. Now, those are two of our biggest inefficiencies. We cannot process calculations fast, and we don't remember things quite easily. If you check out psychology, you hear stuff like, we have a small memory, and so we don't remember things after a while. Now, these are the two parts that the computer does better than us. The computer can remember calculation, can remember things fast, and then can calculate faster. So what the age we're currently in is now the age where man realizes that computers can do this. So what they do is that they tell computers to do the things that they can't do. Okay, so a perfect example would be this is an illustration, not necessarily an example. As most of us know Jumia, right? We have like this rider that comes in the morning to drop our stuff. So some of us that use logistics. One of the things that I'm guessing one of the things that they would do is that in the morning, just before they go and make all the deliveries, they have like different places they have to deliver to. So they have to start looking at their maps and start chatting and start doing calculations and start doing multiplication, addition, and different things to find out the best way for them to take so that they can deliver everything in that day. Even with that, many of them still don't deliver that same day. I'm sure most of us have had bad experiences with delivery guys. So now, what if, since we are so inefficient, we're so terrible, we're so inefficient at determining the best way to deliver different things in a day, what if we wrote a program to a computer that is faster at calculations, that can remember results faster, and then tell the computer that, okay, I'm going to deliver in Lekki today, I'm going to deliver in Aja, I'm going to deliver in Ikeja, I'm going to deliver in Bagada, I'm going to deliver so. So what is the best way for me to go? And then the computer does its calculation. After like 5 minutes, it tells you, go to Agile first, then go to this place, then go to that. And then you can deliver everything in one day. That's basically how the computer is better than us. And it's even better because if, for instance, you're supposed to deliver to a place and then the person calls and says they're not around, that you should deliver another day, you have to start doing calculation again. Somebody has canceled, they have spoiled your plan. You have to start doing calculations again. But then that will take you another 30 minutes. But then the computer can finish it in like what, 3 minutes. Okay, so the computer is very good at performing calculation and remembering results, and that is why it is more efficient than us. Unfortunately, the computer is stupid. Unless you tell it what to do, it will not know what to do. And that is what the program is. A program is basically telling the computer what to do. Does anybody have any questions about all of the explanations? Does anybody have any questions as regards all of the explanations? If you got it, please let me know.
No, you're following.
Okay.
No question.
Great. Godwin, how about you?
No question.
Awesome. Okay, so in this case, it's to perform calculation and remember results. The computer doesn't know how to convert electricity to a number. Although the computer can do this, display result to a screen. We'll get to that later. Okay, so this declarative knowledge and okay, so these two, declarative and imperative, he explains that in the section under knowledge. And basically, declarative knowledge is just saying you're making this a fact, you're saying something that is just factual. For example, Nigeria is a country. That's a fact. That's a statement. That's what you are declaring. You are declaring something, you're declaring a knowledge. So that's what you call declarative knowledge. Nigeria is a country. Our president is a man. Or the earth is round. Or whatever goes up must come down, right? That's declarative knowledge. However, imperative knowledge is now different in the sense that imperative knowledge is the step-by-step process you go through rather before you get to that fact. So for example, whatever goes up must come down. What is an imperative approach to that? You can say, go outside, throw something up. If it comes down, then that fact is true. I don't know if that makes sense. It's kind of like your way of proving that fact. The example that the guy gave in the video was the one about I don't want to get into it too much. Let's just agree that the clarity statement means a fact. Like you're basically saying this is it. You're not giving any story, you're just giving the fact. And imperative knowledge is basically a recipe and how to process, right? And how you want to do something. If you need more explanation, check out the knowledge. If you need me to explain it again, I'll do that, but I'm trying to stay on time here. Okay, so checking in again. Are we all good?
Yes.
Awesome. Okay, so for the next question, a stored program computer is designed to compute precisely one computation, such as square root or the trajectory of a missile. Okay, so for this, it refers to two types of programs. There's one called the stored program and another called the fixed program, right? Calls one the stored program and another one called the fixed program. So the fixed program is basically any kind of computer program or any kind of program really that computes only a limited set of things. A perfect example is your calculator. Your calculator can only do plus, minus, times, division. All those calculators that they use in stores, you can only do a limited set of operations on that. You cannot do something as big as go to the web, or you cannot do something as big as watch a video on a calculator because the number of things you can do is fixed. Another example of a fixed program computer is something that Alan Turing developed. I'm going to quickly just take a sidebar here to talk about Alan Turing because it was referred to a lot in the videos. Alan Turing was one of the, I would say I won't call him the founding father, but was one of the major pillars for computation today. If you research Alan Turing's Enigma, I think, yeah. Okay, yeah. There's a book about it. There's a movie about it. The movie is called The Imitation Game. If you want to research, if you want to watch about it, there's a movie called The Imitation Game by Benedict Cumberbatch. It basically talks about Alan Turing, and then, it doesn't give you a lot of technical details. It just gives you kind of, interesting vibe about him. If you want to research more about him, you can read the book, right? So Alan Turing he wrote a program rather that would decrypt a message. I think that was during one of those world wars. I'm not really a big fan of history, but there was a period when I think the Germans were sending messages to each other, but they encrypted it. And when I mean encrypt, I mean they encrypted in such a way that nobody aside them can read it. Now, Alan Turing created a computer that would basically decipher, or that would basically understand the encrypted messages that the Germans were sending across each other. And then if you watch, this is a perfect example of it. So it's made up of tubes and then a lot of just weird stuff. It's not like the computer that we have today. So if you have the time, just check out The Imitation Game. I think it's on Netflix as well. It gives you a bit of insight into the person. Oh, fun fact, he was gay, and I think he was killed because he was gay. So if you're a social justice warrior, that's something you might find interesting. So the guy refers a lot about Alan Turing, and that's because Alan Turing created a fixed program computer that was specifically designed to decipher the Germans' messages. So as opposed to a fixed program computer, a stored program computer, on the other hand, basically allows you to run different programs on it. And I think I showed some of you before. When you store Python, for instance, you can create multiple scripts. You can have a program that would, that will go to Facebook and collect all of the names of your friend on Facebook. You can have a program that would download all of the movies from a site. You can have a program that will go to Twitter and check out how this guy is trending. One of your BBN stars is trending. And all of these programs are doing different things, but all of them can run from the same computer. So that's what you call a stored program computer. Does everybody get that? Does everybody get that?
Yes, yes.
Okay. Godwin, Smith, Sherwin, Blessing, I need.
No, no.
Yes.
I didn't get that one.
Okay. Okay, let me go over it again then. A stored program computer and a fixed program. There are two types. Let me just open a new tab there. A stored program and fixed program computers. So you can basically just do your research on this. So just to reiterate for the sake of lesson and any other person that did not get it, it's a fixed program computer is any program or any programmable device. Let me use that word. Programmable push. Oh, wow, that was difficult to say. Programmable device that can only do one thing or a limited set of things. A perfect example would be a calculator, right? A perfect example would be a calculator that does plus, minus, addition, division, sine, cosine. The number of things you can do in a calculator is limited. You cannot, for instance, say you want to draw a graph on a calculator. That's not possible, right? So another example of a fixed program computer, I mentioned that there was something that Alan Turing did. Alan Turing was one of the popular pillars of programming and computer engineering science, rather. If you want to find out about him, you can check out The Imitation Game or read his book, Alan Turing Enigma. He was a very intelligent computer guy who created a computer specifically to decipher a code during the war. That was all the computer did. The computer did nothing else other than that. If you're a good reader, I think the book will probably give you more insight than the movies, because movies are more, they're just Hollywood side of the story. They're not necessarily true. So if you want to really understand it, you can read the book. But when he created this computer, all the computer did was to crack the Enigma code. And that was the message that the Germans were sending between each other. That's all he did. I don't think he did plus or addition. No, he didn't do any of that. It had a specific function. And that's what you call a fixed program computer. A stored program computer, on the other hand, can run multiple things. The computer in front of you right now can do multiple things. You can open your calculator, you can go to Instagram, you can watch a video, you can take a picture. I'm speaking generally now. As we go further into our programming class, you see that you are going to be writing multiple scripts that will be doing different things, and all of them would run on the same computer. So what this basically means is that you can store a program on your computer and run it. Does that make sense now, Blessing? Blessing, does that make sense now?
Yes, yes.
Okay. You're welcome. If you do not understand, it's fine. Just let me know. I will totally go through it again. If you don't want to say anything now, you can let me know after. Doesn't change anything really. Okay, Smith, are you with us? You've been quiet lately. Smith? I think Shola Smith, yeah.
I'm with you, sorry.
Okay.
I was talking without unmuting.
Okay, all right, gotcha. Shehu, you with us, yeah?
Yes.
Awesome. And you're getting everything so far, right?
Yes.
Awesome, thank you. So that basically answers this question. Many of these questions, okay, so this says computer works through a sequence of executing some computation. That's basically how all programs are. Programs are supposed to run step by step, one line after the other, one line after the other. Let me just show you. You're going to learn some more, obviously, about programming in Python. But let me show you an example of a Python script. First, I say print hello world, and I say welcome to the class. I say hope you're good, and I say bye-bye. Now, if I were to store this program and call it tests. Let's say join the speeding it. Let me call it test and I run it. Basically, what's happening here is that, sorry, minimize that. What's happening here is that it runs the first one, hello world, print it out. Then runs the second one, welcome to the class, print it out. Then runs the third one, hope you're good, print it out. And then runs the last one, bye-bye. So essentially, programs, and this is not just Python, all programming language runs sequentially from the beginning, one by one. They go from one line to the next line, all the way to the end. Sometimes they can jump. An example, okay, I'm not teaching you programming now, let's not go too deep into that. But sometimes they can jump. The answer there is that the computer executes the program in linear sequence. Yeah, this is it. The computer executes the instruction in a linear sequence. A linear sequence just means one after the other, except sometimes it jumps to a different place. And all of this you understand better when we talk about, I think we have it in our syllabus here, the idea that the computer can jump from one place to the other. You will understand that when we're talking about control flow, decision making and loops. So, but for now, trust me, as you were, that a computer executes its instruction one line, one by one, basically a linear sequence, but sometimes it can jump from one line to the other. Are we all together? Blessed, welcome on board.
Yes.
Can you hear us? Blessed's mic is not active. Once it's online, you'll let us know. Okay, so in order to compute before I go on, everybody got that? Godwin, Blessing, Shem, everybody.
Yes, I do.
Blessing? Okay.
Yeah.
Godwin, did you get it?
Yeah.
Yes.
Okay. All right. I trust that everybody's getting it. So I think one of the confusing one was this guy. It says in order to compute, let me just oh wow, there's still 3 more left. In order to compute everything that's computable, every computer will be able to do the 16 most primitive. So what's funny about this is the reason why it is false is because it's not 16, it's 6. The guy references in the video. Some of these questions are just questions that, if you watch the videos, you understand. Yes, every computer can only work. They must be able to handle the primitive operations, but there are not 16 of them. There are only 6 of them. So I think some of you selected false because the question looked tricky, but the statement is correct. The only thing that is wrong about the statement is 16. It should be 6. And that's what makes this statement false. Do you guys understand that? I'll explain what they are, those 16 operations. We're going to be talking about them as we go through each of our topics. But for now, keep in mind that there are 6 of them. Does that make sense? Okay. 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 So this is the last part. The 3 rules of programming, as you were: syntax, static, semantic, and semantic. And now this part is particularly interesting because I think that the guy really did a very good job explaining it. He did a very good job. Sorry, excuse me. He did a very good job explaining it in the last video. Let me get it for you real quick. Yeah, and language. So I know, I suspect rather that some of you found it difficult to grasp, but in this last video, check it out again. He did a very good job explaining this to me. And basically, he compared writing a program to speaking English. That's basically what he did. Compared writing a program to speaking English. So it says in English, we have some words. Sorry, let me rephrase that. Every language, whether English or programming, they have a set of words that you can combine together, right? I think Godwin is done. Okay. A set of words that you can combine together. So in English, you have nouns like the name of a person, the name of a place. You have pronouns like I, blah, blah, blah. So those are words that you have in English. In the programming language, you have what we call keywords, which you start to see more of. I don't know if I can show you them now. You have keywords, and then you would have just normal words. They are made up of numbers, words, keywords. An example of a keyword just for you to know now, if you are typing it and the color changes, know that it's a keyword. Right now, this looks like a purple. It's not black. That's a keyword. Another example is DEF. The color changes. That means it's a keyword. What that means is that Python has reserved that particular word for something in their library or whatever. So you cannot use that as your variable. We'll explain more of that later. But what I want you to understand here is that, like English language, Python language has words, has statements that you can use, right? Now, we have a way of putting words together. So in English, you can put a noun. I think the structure of an English of a sentence is you have a noun, then a pronoun. I'm not an English instructor, but I'm just guessing You say something like, you have a noun or a pronoun as the first statement. They have maybe a verb or a preposition, blah, blah, blah. So an example of a statement would be, I am awake, right? I am awake would be an example of a sentence in English language. Now, if I were to remove for instance, and say awake, that is not a valid English sentence. That's obviously not valid, because what does that even mean? Now, you will tell somebody that this is an incorrect English sentence. Now, in Python as well, the way you combine words will determine if it is a correct syntax. That's what I mean. The way you combine words will determine if it's a correct syntax. So if you combine words wrongly in Python, or if you combine keywords or whatever wrongly in Python, and they are not, they don't follow the normal standard, Python will tell you that you have a syntax error. A perfect example would be, this is a string, and then you do this. This is an illegal thing to do in Python. If you try to run it, Python will tell you error, invalid syntax. I know this can be a bit tricky, and I'm really trying my best to break it down. But essentially, whenever you don't structure your code properly, whenever you don't structure your code properly, you don't put the right words after each other, you would have a syntax error. But did you want to say something? Godwin? Okay. You know what? I think this syntax, static, semantic, and all that is confusing people. So I'm just going to put that one on the side for now. Again, if you don't understand that part, check out languages. The good thing is that many of the things that we've learned here are, like I said, some of them are just so fit your curious mind. The most important thing that the guy tries to explain in all of the videos is that you as a programmer must learn how to think through your problems. You must learn how to create recipes for solutions. You must learn that, okay, if somebody gives you a problem, how do you solve that problem? Come up with a step-by-step process of how you solve that problem. And obviously, when you're doing programming, you're going to be dealing with computations as well. So you have to start thinking about how you solve problem computationally. Don't worry, all those words are big words. By the time you start to take tasks and assignments, they'll start to make more sense to us. Does everybody get that now? I'll need oral confirmation that you all got that. If not, let me know as well.
Yes, I do.
Okay, lesson. It's fine that you didn't get it. I think that at some point I started to confuse myself as well. So did you understand it?
Yes, I do.
I can sense a bit of a no under that yes, but we'll get back to that. Godwin, how about you? Did you get it?
Yeah, following that.
What did you say?
Following.
I can't quite hear you.
I said I'm guessing.
Okay. Obviously, it's fine. Sometimes it can be difficult for you to understand it. Many people who learn programming had already like a previous foundation in something related to it. Maybe they did some kind of mathematics or computer science or whatever. And if you have not done any of that before and starting out, it is okay that it can be confusing. What's important is that when you are confused, you ask questions and then you clarify. Okay, that's what's most important here. If I'm not doing a good job explaining it. Give me some time to review, and then I'll come back to explain it again. Okay. All right. So, Smith, how about you? Did you get that?
Yeah, I'm good. I'm good,
All
but
right.
I'll just need to watch the video again.
Okay, great. Blessed, welcome. You came in a bit late. We've gone through a number of the questions on the programming. Blessed, can you hear us?
Yes, I can.
Okay, good. So I was saying that we've gone through a number of them already. I would obviously post this video online if you want to review what we talked about. Again, I think towards the end there, when I started to talk about this last three, it got a bit dicey. So, I think I'll probably need to figure out a better way to explain it to you guys. All right. Aside that, I think that's pretty much everything. Everybody did perfectly well with the quiz, although this week I'm about to go to, I'm not doing quiz. We might do some quiz, but it's more about hands-on. You're going to be writing scripts. You're going to be submitting assignments. This week we're dealing with variables, data types, and casting input and output. So if you've not set up your Python on your computer yet, there's a video for that already. If you've not done that, you should do that now or today or earlier this week rather, because the task that you're going to have this week will require you to write a Python script. So make sure you've installed Python so you can run tests and all of that. Okay. Yeah, I think that's pretty much everything I have for today. I'm going to post the materials for this week's topic on the Google Classroom. I'll let you guys know when I do that. I'm going to post the task. Either I post the task today or tomorrow. Either ways, you get to see it before Wednesday, so that on Wednesday, when we have a question and answer session, you can answer the questions that you have, and then submit your script by Saturday, so that next week Sunday we can have another code review. Does that make sense to everybody? Okay. All right. On that note, I think so far it's been good.
Yes.
Thank you for popping by. I would make the recording available in the Google Classroom as well. Yeah, and obviously if you have any questions, please do not hesitate to reach out. That is the most crucial part. Reach out if you have any questions, regardless of how stupid it sounds. Reach out, unless you're clear, because we're going from topics to topics and we're going to be moving at a fast pace. So if you don't understand something now and we start to give you more, you just, the foundation will basically just spoil. So please, if you have any questions, do reach out. Okay. Thank you guys for coming. Have a good day.
Thank you very much. Good night.